All right, so this chapter is on circles. The first lesson here, it says you can see that we're going to learn about lines and segments that intersect circles. Some terms will be in this one as all well as some properties that they give us. So some of the terms we'll see and recognize, some of them will be new. So identify special segments and lines, draw and identify common tangents. We'll talk about what that means. And then to use some properties of tangents are our learning goals for today. So first of all, to identify special segments and lines, we have to know how to name a circle and the definition of a circle. So it's the set of all points that are equidistant from a center is the definition of a circle. So all of the points that are equally far away from point P is the definition of a circle. We always name it or label it like this down here. You write the word circle and then a capital letter for that center point, or you draw the little circle with a dot in the middle and label it. Okay, so here's some of our key terms. Again, pause the video and write these all down, but make sure you understand what all of them are. Radius and diameter should be pretty familiar to us. Radius is from the center to the circle. Diameter is from endpoint through the center of the circle to another endpoint on the circle. The new segment inside of the circle that we're going to learn this section is called a chord, and it's basically touching the circle in two spots everywhere except for through that center point. So chord is the new one that we know. The new lines that we don't know are called the secant. So again, a secant is just kind of a continuation of a chord. It's going to cut outside the circle. And then this last one, again, that becomes very useful when you get to trig classes, especially in calculus, is called a tangent line. So a tangent line intersects a circle at just one point. Again, that point where it intersects can be called the point of tangency. So identifying the points here, or the segments or lines here, again, notation is important, but an example one here, AC, we can look at and we can see that this is the radius. Okay, AB, that segment is the diameter. Ray DE is going to be a tangent. And then line AE is going to be a secant. Okay, so again, these are just some of our terms from up above. So in this one, in the monitoring progress, I'm going to do note checks this chapter. So what I'd like you to do is have your notes handily available for me about every other day, and I'm going to do a note check. Here's the first one that I'd like you to do in your note check. So note check, and I want you in your notes to please label, so 10.1, and then if you could just call it like note check like this, and then you can do number 1 and put the answer, and then number 2 and put the answer. So please label and name segment AG and then segment CB for number 1. And the image is right over there to our right, and it says name a tangent and a tangent segment as well. Okay, so I am going to check your notes for these this chapter throughout the chapter, and that will be kind of part of our homework grade. Okay, so make sure we get those note checks down. Okay, core concepts. So we have coplanar circles, meaning circles in the same plane. We have a couple things called tangent circles and concentric lines that we have to learn about here. So concentric circles simply mean they have a common center. So we won't see these a whole lot because they're not super useful to us, but concentric circles have a common center. Tangent circles we'll see a little bit more where they touch at one point because it gives us some useful properties. And then you can see over here we have these two circles that intersect at two different points where they overlap like that. So those are our kind of three options: 2 points, 1 point, or no points of intersection. Now, what they ask for in this part is common tangents. In other words, how many tangents could I draw to intersect these? So on the 2 points of intersection, again, bear with me on the drawing, but I could draw 2 common tangents that go through my circles like that. Okay, if I have 1 point of tangency, I'm only going to have 1 common tangent. Now, the concentric circles, we're going to have no common tangents, but the ones that are non-concentric and non-intersecting, we actually have 4 tangents. We have one that goes through on either side, and then we have, again, the tangents that go on the outsides. So we have those ones that are diagonal, and we have the ones that go on the outside, just like when there's 2 points of intersection. But understand what a line of tangency is. It's just going to touch each of those circles at one spot. Okay, so again, I kind of already did that up above, but on A, we have 4 lines of tangency that we can draw, the 2 along the outside. And again, bear with me, it's not going to be perfect, and then the 2 through the inside, but those are my tangent lines. On B, we have the 2 lines of tangency go through the outside. On C, the 2 lines of tangency also go through the outside. And actually, it looks like on B, I missed one here. There should be a point of tangency where they touch at that one spot in the middle. So the answer should have been 4 lines of tangency, 3 lines of tangency, and 2. So again, we have another note check. Please make sure you draw these circles in your note check so you can just add them below those other ones in your note check. So for this section so far, we should have 5. Again, you can draw the circles, the common tangents, or just put the number of common tangents on there. I'll take that too on this one. But it really does help to draw them out so that you understand what they look like. All right, so tangent line to a circle theorem. First one we have here, it says in a plane, a line is tangent to a circle if and only if. Again, that's key notation. That means we can read that backwards or forwards. But it says if and only if the line is perpendicular to the radius. So what it's saying is this line is tangent so long as the radius is perpendicular to it. So if I have a radius that's perpendicular to a line, I know that line only touches my circle at one point, and that's the point of tangency. The other thing says if I have 2 segments coming from an external point on a circle, if they are congruent, we know that those are both tangent segments and they're equidistant from my circle. So it's saying if SR is congruent and ST are tangent segments, then they're going to be congruent. So again, we can go either way with that. So on example 3 here, it's asking if it's tangent. Now, if we think about what it's asking if that is a right angle. Well, what they've constructed for us, if you'll notice, is that's a right angle and it's opposite aside, and they've constructed us a triangle. So really what they're asking is 12 squared plus 35 squared equal to 37 squared? In other words, is that a right triangle? And if it's not, that's not a 90-degree angle, and that's not a point of tangency. So I can pull up my calculator here. 12 squared, not now, 12 squared plus 35 squared, and I hit equals. And if that's the same thing as 37 squared, which it is, I can say yes, these are both 1369. I can say yes, that's a tangent line. So ST is a tangent line because that formed a right triangle, and this is a 90-degree angle. If that's not 90 degrees, your answer is no. If the Pythagorean theorem doesn't work, your answer is no. Okay, this one's a little more challenging. Now we have to know how to set this up. So it says in the diagram, point B is the point of tangency. So we know for a fact that this is a right angle. Now, when I go to set up my Pythagorean theorem here, I have r squared plus 80 squared. And again, this is the part that's weird. My hypotenuse is actually this, 50 plus r quantity squared. So in order to solve for this one now, what I have to do is FOIL out r plus 50 quantity squared. Again, it's been some time, so I'll work that out off to the side here. So r plus 50 squared, when I FOIL first times first is r squared plus 50r plus another 50r. And then 50 times 50 is plus 2,500. And again, that's all equal to r squared plus 80 squared, which I can just write as 1,600. Now, when I go to solve this, if I pay attention to what I have going on, first of all, if I subtract the r squared over here to combine these like terms, those will cancel away. Now, that won't always happen, but in this case, it makes life a little easier because now I just have a 2-step problem. So now I have 100r plus 2,500 is equal to 1,600. So if I subtract my 2,500 over there, what I need to do here is take 16 minus 2,500. So 1,600 minus 2,500. negative 900. And then I can divide by 100. And I get r is equal to negative 9. So we have to make sure we solve that outright and square that. Again, if I double check that, actually, and I think I did my math wrong now that I look at that, because what's 80 squared? I need to fix that. See, I make mistakes too. Hey, how about 6,400? That was a big blunder. We're going to fix that 6,400. That's going to change my answer big time. Holy cow, sorry guys. So let's go back and fix that. How about 6,400 minus 2,500? And that will give me a positive answer. Good thing I looked at that. So if I go back, that would have been 3,900 divided by 100. Holy cow. I apologize, guys. It's late, and I'm making some math errors here, and I tried to do that in my head. So r is actually equal to 39, not negative 9. That makes more sense. So again, there's one of those cases where even your math teacher made sure check for reasonable answers. We don't really want a negative radius, so I went and made sure I did that. So big question here, what's the difference about this example and the previous one? Make sure we FOIL that out. And again, double check your numbers because even myself, I make those mistakes. Okay. I like to throw these in when they have them in the book. Again, you guys, because part of what we're supposed to do is know how to use these tools. So again, here's one of our opportunities for some bonus points. We'll do +2 on our mid-chapter quiz if you have this constructed and turned in to me before the quiz. So you just follow the steps here in this little construction thing and use only, again, we only want to use a compass and a straight edge for all of these. Make sure you're doing that to construct your tangent to a circle. Okay, last one here. Again, this one's quite a bit easier than that one that we had up above because it's pretty straightforward. It's saying if these are both tangent, they should be equal to each other. So we get 3x, we subtract over that 4 is equal to 24. We can divide by our 3, and we simply get x is equal to 8. Okay, so again, these should be congruent if those are tangent lines to that. So again, our last note check here. And again, make sure we have all 8 problems. So we should have problems 6, 7, and 8 with work in our note check. Again, this will be part of our homework grade. For the chapter, it will be kind of a separate grade at the end. So note checks 1 through 8 will be due on paper at the end of each section. I'll have you guys show those to me. If I don't get them, make sure you guys remind me to get those in the grade book for you. All right. So again, in summary, we should have went through all of those terms. Make sure you understand not only radius and diameter, but also chord, tangent, and secant. Point of tangency is also important. Make sure you can draw and identify tangent, use properties of tangents. Again, guys, always ask questions if you have them. Make sure you have well-organized, good, clean notes. I'll be able to come check those skill checks here soon. Thanks, guys. Have a great day.